Now, our first workshop today is presented by Dr. Pariza. Pariza is currently associated with Sarvajanik College of Engineering and Technology, Surat, as a professor and head of the Computer Engineering Department. She has more than 25 years of teaching experience in various reputed engineering colleges in India. Pariza will present the workshop, Effective and Ideal Presentation Using Visualization Techniques and Lucid Perceptions. Please welcome Dr. Pariza.
Thank you so much, Laura, for a lovely introduction. So let me share my screen first. I'm starting with the topic of today's workshop, that is effective and ideal data presentation using visualization techniques and their lucid perceptions. So basically, if we talk about data visualization, it is a very important phase of data science life cycle, and it is a combination of art and science both. Whenever data visualization is done effectively, then the consumption of data by the end user, it happens in the form of a long-lasting story. And then it helps to understand the significance of the data efficiently and effectively. So nowadays, every company, every MNC, they are based on data visualization for their better business decisions. This is an image which I have taken from a book, Knowledge is Beautiful, by David McCandless. He says that there are 4 segments or pillars of data visualization. The very first is information, that is data. From this data, which should be considered as accurate, consistent, and honest, we can tell any story with a purpose goal, with a appropriate goal. And then we can do the visualization in appropriate form. So basically, we can say that effective data visualization, it is about presenting the right amount of data in right order, in the right visual form, to the right audience for the right purpose. So that is all about the effective data visualization, which we have to take. Then the information can be communicated nicely without any fuss. So we have to take care that the data which we are using to represent any visual form, so that should be in appropriate detail. If we are presenting too much data, then also it is not good, because in that case, consumer might lose their interest. And this data should not be curtailed too much, because in that case, meaningful insight can be lost. There can be 2 types of data visualization, exploratory and explanatory. Exploratory is during the analysis of the data, wherein we are trying to find out various kinds of information about the data, what is the data, and what are various information inside the data. In explanatory, what we do, we have done the analysis with our data, and then we want to present the insight about this data to our audience. So 2 types are there by which we can represent data visualization, either in the static form or in interactive form. Interactive, basically, wherever you can consider more details, you can create new insights, and you can change the parameter of the data visualization during the visualization. If we talk about the design principle of effective and ideal data presentation, so there are certain rules for that. So the very first rule says that we should understand the context first. What is the audience? What we want to present, how we want to present, and what is the data by which we want to present the information. Then we need to do the appropriate selection of the data visualization. For example, if I want to represent the trend among the values, I should prefer line graph. If I want to compare elements, I should go for the bar chart. And if I want to show the contribution of a particular element for a whole or for a 100% contribution, then the pie chart is a good thing. To represent the data distribution or frequency, we can go for histogram or KD plot. And if we want to find out the skewness of the data, dispersion of the data, and outliers in the data, box plot is the right choice. And for representing the relationship among variables, we can go for the scatter plot. So these are various kinds of charts or plots we can select for the visualization. Next rule says that statistical charts should be drawn in 2D instead of 3D. That is the preferable choice. Wherever you want to put the text to provide extra information to the users, in that case, it should be done carefully and intentionally. And the very important rule is that there should be a high data ink ratio. This data ink ratio is basically the ratio of data ink to non-data ink. the ink which is used to represent the actual data, and the total ink which is used to represent the whole graphic. So we should have a high data ratio. You can see here, I have given example of two things. One here, in this case, we have on the right side, we have the high data ink ratio. So the data or the visualization is very neat and clean. Where in the case of low data ink ratio, we are using too much ink for the information which is not very useful. So the main emphasis that we should have a high data ink ratio kind of visualization. Then we should focus our attention on the important parts. So for that purpose, we can use various kinds of retinal encoding, like various kinds of colors, sizes, orientations, hues. So we can emphasize our data, any important part, with the help of this retinal encoding. And the best part is that remove to improve. So if you want to represent many information into a single plot, that is not a good idea. So instead of that, we can go for individual plot that should be as simple as possible. And then we can utilize multiple plots to make comparison, to show trends, to show relationship. So instead of putting every information into one single plot, we should prefer multiple plots. If we talk about various libraries for plotting, for visualization in Python, so we have all these in our hand: Matplotlib, Seaborn, ggplot, Plotly, Bokeh. Matplotlib is very important because most of other libraries, they are developed on top of Matplotlib. So even if you want to do some plotting in Seaborn, you should also import Matplotlib, and then over that you can plot various kinds of graphs with the help of Seaborn. Regarding the installation, if you have Anaconda distribution already installed, then Matplotlib and Seaborn both are pre-installed into that, so no necessary further action is required. But otherwise, you can install these with the help of simple commands, either using conda install or pip install. Now coming to the coding part, I'm here in this cell. I'm just ignoring the warnings, which might be generated due to the application of various features because of the version difference of the Matplotlib and the Jupyter Notebook. In next cell here, I'm importing various important libraries which are required for this particular visualization. So I have imported pandas, numpy, Seaborn, and pyplot from Matplotlib. I have also set a color coding of the Seaborn. So I am using sns.set, and then I'm setting color codes equal to true. So I would be hitting certain default configuration which are available in SNS, that is Seaborn. This is just to check the version of my Matplotlib. So my Matplotlib version is 3.4.3. Now this particular code, it is for the Colab users. So if you are using this notebook in your Colab, in that case, this cell needs to be executed to upload the data set into your Colab. So the data set which I have already provided, it is named as cars3_clean. Why this name I have given? Because I have already done a lot of pre-processing onto this data. And because now the purpose of the workshop, it is only for the visualization. So I have omitted that part of data pre-processing. So here in this cell, I'm uploading my data set into Colab. And then there is a default column, which is unnamed 0. I'm dropping that column. So in DF data frame now, I'm having the data set without this column. This need not to be executed if you are using Jupyter Notebook. Then next cell is to be executed if you are doing in Jupyter Notebook. So herein I'm importing my data set. I'm converting that into data frame, stands as DF. And again, I'm dropping the default column unnamed 0. I have provided here the absolute path for my data set. I hope you're synced with me. So when I display the data frame here, then you can see that in this data set, I have total 410 rows or data points, and in all 10 columns or 10 features. And out of these 10 features, the MSRP, it is my outcome variable, and remaining all 9, they are my input features or predictors. So my purpose of this visualization is that after doing certain more analysis with the help of visualization technique, I want to create a data model. And for that data model, I need to process little more with the help of visualization. So the purpose is that I want to predict the price of the car based on the predictors which are there in the data set. So let's go further. Now, when I want to plot in Matplotlib, so there are two interfaces. One interface, which is functional interface, which is PyPlot, and it is very similar to MATLAB. Other feature or interface is object-oriented. So I'll be telling you wherever, in which particular cell I'm using the object-oriented interface. Mostly in all the cells, I'm using PyPlot interface. Coming to the backends, which are, there are a lot many backends available in Matplotlib, but two are the popular one. Inline backend, which creates the static images or non-interactive kind of, and this can be implied or utilized with the help of this syntax, %matplotlib inline. Another one is notebook backend. So if I want to render, if I want to plot something interactively, in that case, I can go for this backend, and it can be utilized with the help of this syntax %matplotlib notebook. So this is basically to generate interactive plot. Now I just want to check what kind of backend right now I have. As I told you, inline is the default one. So when I'm running this command, I'm getting output that inline is the backend currently I'm using in my Jupyter notebook. Then beside this, Matplotlib, it has many styles available. So in those styles, there are predefined features that there would be grid or not, there would be background of which color, line what would be, the line color what would be. So all that, it is set into certain styles, and you can directly use those styles available. So if you want to see what are the styles, you can run this command. You can import a style from Matplotlib, and then if you're running style.available, you would be getting the names of all the styles available. Currently in this cell, I'm using ggplot. So I'm using ggplot style of Matplotlib. And here in this particular cell, I'm telling you about the object-oriented interface. So if I want to go for the object-oriented interface, I need to create the figure instance and the axis instance. And thereafter, I can put all the graphic components utilizing AX. So basically, figure is the whole area, whole canvas, which is this area. And then onto that, I have plotted axis, which is rounded rectangular box, to which I have the x-axis and y-axis. And over that, I can plot either the line plot or the bar plot or pie plot, whatever I want to be. So this is about plotting the line graph. So line graph is whenever I want to see the trend in my data, I can plot the line graph. Here, I want to plot the line graph for my MSRP feature, which is my outcome. So I have taken those values of the MSRP into values variable, which would be my Y values. And for the X values, I have taken a range from 0 to 410. Why so? Because total data points are 410. So I would be having 410 values for MSRP. And that's why I need same number of values for my x-axis. Then I'm plotting a line graph between my x values and y values. So here you can see from this line plot, it gives me an indication that very few cars are having very high price near to 2 lakh. Otherwise, most of the cars, they have a price less than 1 lakh. So this is a trend about the price of the cars. If I want to plot number of lines onto the same plot, it can be done easily. I can also add various other graphic elements like the title for a graph, label for the X and Y axis. Then there could be legends for my various kinds of lines if they are there on the single plot. I can mention annotation, special information or notes for my users. Then I can do the customization as well. So I can set the line width, I can set the line style, line color. Similarly, for the marker, I can set their color, their style, and their size. Similarly, I can even override the range for my x-axis and y-axis. So these are various kinds of lines I can represent. If a solid line is to be represented, a single hyphen. Otherwise, two underscore, they are for dash line, likewise. Similarly, these are marker style. So capital D stands for diamond. I can use star for my markers. I can use plus sign, maybe cross sign, maybe small g. And then utilizing those, I can represent a very nice informative plot. So let's see here, in this case, I'm plotting 2 lines. So for those 2 lines, I have taken 2 features. First feature I have taken from my data frame, which is mileage in city. And from this feature also, I'm taking only initial 50 values with the help of ilog. So I have taken first 50 values of my this feature, MPG city, which I would be representing on my y-axis. So for x-axis, I have taken the similar number, same number of values, that is range from 1 to 51. So total 50 values would be there for x-axis as well. Now I'm plotting first line between x1 and y1, to which I'm mentioning the line style as dash, that means solid line, the color as green, width I have mentioned as 1. This is my marker style D, which stands for diamond. Marker size is 4, and I have given label for this particular line, x1, y1. Similarly, for line 2, I'm taking engine size feature and the very first 50 values of that, which I'm going to plot on y-axis. Similar here also, I'm taking the same number of x values, so I'm not creating them again. This second line is plotted with values x1 and y2. It is of red color, solid line, same width. Marker I have taken as circle here and a label to my line. After that, I'm changing, overriding the default limit of y-axis. So that limit I'm taking 0 to 30. Otherwise, what happens if I'm not mentioning this? So limit for the x-axis and y-axis is decided by default by matplotlib based on the values which we are representing on x-axis and y-axis. After that, using these methods, x label and y label, I have provided a label for x and y-axis, a title to my graph, and then I'm using legend method. So whatever labels I have mentioned for my lines, label 1, label 2, those would be displayed if I'm using this method legend. And where the legend would be displayed onto the graph, the location is 1. This location 1 represents upper right corner. After that, if any extra information I want to provide to the audience, I can annotate that with the help of this method. So I'm providing the location coordinate and text whatever I want to represent. So you can see here, there are 2 lines and I'm getting the legends. Green line represents the mileage in city and red line represents size of engine. I have annotated here representing that this particular point, it is representing lowest mileage. So this is about multiple lines which are plotted onto the same graph. I can also add X's, text, and grids to my graph. And this X's and ticks, they can be represented with the help of these methods. Like here in this particular cell, you can see that I'm using object-oriented interface. Till now, I was using PyPlot. But here, to create the object-oriented interface, I'm using explicitly, I'm creating the object of axis. So AX is the instance of axis. Now using this axis, I'm setting the limit for my x-axis and y-axis. I'm providing ticks values for my x-axis and ticks value for my y-axis. And thereafter, I'm adding a grid also. So I have added the limit, I have changed the limit, x and y limit. I have provided the ticks for x and y, and I'm adding the grid. So what kind of grid I am adding? Both I have said. That means I want horizontal grid as well as vertical grid. The color for the grid I have mentioned as blue color. The line for the grid is dash, that means solid line, and the width is 2. And to represent the data, to represent the line, I'm using the same data which I have created in the previous cell, x1 and y1, which was for the mileage, and taken a color red, solid line width is 1. What perception you are getting from this graph? So isn't it a low data ink ratio? Because the line or the data which I'm representing, it is actually not dominating. What is dominating? It is a grid. And you can see here, most of the ink which is used to plot this plot, it has been utilized for plotting the component which are not meaningful. what is meaningful is my data, this red line, which is very light, and it is really difficult to emphasize this data in this plot. So it is not a good kind of plot. It is just to give you a demonstration that it is not a good plot because it is having low data inc ratio. Yeah, next coming to pie chart. So here in this case, I want to plot a pie chart to represent that how many cars are there of particular cylinder number. We have seen, no, there is a feature cylinder. So that represents what are various number of cylinders in a particular car and what is the count of such type of cars. So for that purpose, I'm using my feature cylinders, and I have applied a method value underscore count. So this method would be giving me all the unique values which are there in this feature. So unique values would be number of cylinders. What are various number of cylinders in the cars? And I would be getting a count for all the unique values. So this variable of mine, it would be representing a series kind of data. I'm printing this value, this variable, and you can see what I'm getting. I'm getting an index column, which is having unique value in the cylinder feature and the count of those. So that means the total number of cars which are having 6 cylinders, they are 185 in number. And total number of cars which are having 3 cylinders, they are only 1 in count. So I'm getting 2 column, index column and values column. Now after that, because I want to represent a pie chart, and this pie chart, it is having 2 things, the label, which is represented here 4, 8 and 6, and the portion of every wedge as a contribution to the whole 100%. So I need 2 things, labels as well as the portion of the wedge. So for that, what I am doing, from this variable, from series variable now, I'm extracting index, which is a unique value. So that I would be using as a label for my pie chart. So if I'm printing labels, so I would be getting output like this, 6, 4, 8, 5, 12, 10, and 3. So in all, there are 7 values, 7 unique values. Then value column, I'm taking as a portion of every wedge. So that portion would be in the form of percentage. And now because there are 7 different values, I have taken 7 different colors. I have taken explosion for every wedge. So I'm only exploring one wedge, which is the dominating one, which is having 6 number of cylinders. And after that, when I'm plotting my pie chart, I'm providing the portion, I'm providing labels, colors, what would be the start angle for the pie chart. I have set false for shadow and then explosion. Radius for the pie chart is 0.8. This is a contribution decimal with 2 decimal places. And I have set counterclock as false. There is a title also given for the plot. Now you can see here, my plot, it is starting with 90 angle. The first wedge starts with 90 angle, and then it is going to clockwise direction. So this is my second wedge, this is my third wedge, and remaining wedges, they are not so clearly visible here because they are having very less proportion in the whole contribution. So from this now, you can conclude that there are maximum domination of the cars which are having 6 number of cylinders. Next, we are now plotting the bar chart. So for plotting the bar chart now, I'm taking the same values, the proportion of every car, the count of the car which are having different kind of cylinders. So this I'm representing here with a new variable frequency because I want to plot the bar chart. So I'm setting the width for all the bars. So how many bars would be there in this case? Because unique values are 7, so there would be 7 bars. So I have taken same color for all the bars except a different, width, same width for all the bars except a higher width for the bar which I want to highlight. Similarly, in colors also, I'm taking same color for all the bars and red color for the bar which I want to highlight. For the tick labels, now here I have taken the index column. So bar plot is plotted with tick labels, frequency, widths I have specified, and colors which I have specified. Now, because it would be very difficult to guess exact number of the cars, so for that purpose, I am printing the exact value over the top of the bar. For that purpose, I'm using a for loop here, which I'm iterating over 2 variables, I and b, and This is deciding the X value, X location. This is deciding Y location, X and Y coordinate, and the label which I want to print. So value I want to print there, which I have converted to string with a blue color and bold font. So now you can see that I am getting a bar graph wherein all the bars of the same color, and the bar which I want to emphasize to the audience, it is having a different color and it is having a size also bigger than others. So this is to emphasize the data which I want to represent to the audience. Now coming to data distribution, again, it is very, very important, because with the help of data distribution, you can represent that what is the total range of the data of a particular feature. What is the central tendency, whether it is having a central tendency or not, whether it is symmetric or not, or is it skewed in one particular direction, maybe towards left or maybe towards right? Is there unimodality or bimodality or multimodality in the data, or are there any significant outliers? So for this purpose, this is very important actually. Data distribution is very, very important in the form of visualization, because we know that a picture is worth 1,000 words. So that's why lot many information can be communicated to the user with the help of such kind of data distribution visualization. So for that purpose, we have either the histogram or density plot. In histogram, they're like your bar charts only, but here the X range, it is divided into equal size of bins. And then the value of the X range, it is divided into categorical variable, because now we are representing a whole bin as a categorical data, right? So it would be representing a range for every bin. And other one is the density plot. So histogram, they represent the data in the form of frequency, like your bar chart, but density plot, they show or they represent the data distribution curve as a smooth curve. So let's see both of them. Now for plotting the histogram, I am again taking my outcome variable. You can do this for all the features which you have, for all the input variables as well as the output variable. But to demonstrate, I am only representing here for the outcome variable. So I have extracted this feature. I have stored that in this particular variable, MSRP. Now to find the range for the x-axis, I have found out the minimum and maximum of this feature. So if I am printing the minimum and maximum value, you can see the minimum price of the car is 10,280, while the maximum is near about 2 lakh. So that means my range for the x-axis, it should be within this limit, 10,000 to 2 lakhs. So this is the range for my x-axis. I have decided the number of bins as 8. The default number is 10. So that means this whole range would be divided by 8. So I would be getting equal size 8 bins. Now, if I want to plot the histogram with the help of matplotlib, the command is hist, to which I'm passing MSRP, number of bins, the total range for x-axis, color for bars, and the edge color for the bars, it is red, the color for the bar is green. Histogram type I have taken as a bar, so it would be very similar to your bar graph. And the width for every bar, proportionate to the whole bin, I have taken 80%. Alpha represent the opacity of the bar, so any value near to 1 would be opaque, and any value near to 0 would be transparent kind of bar. I have given this label for my histogram. So this label would be represented with the help of this legend. I have given X label, Y label, and a title. Now you see, I'm getting an output like this. So this is my x-axis label, y-axis label. I'm getting bars because I have taken 80% of the whole bin, so I'm not getting the consequent bars. If you are taking this value equal to 1, so all those bars would be connected 1. And from this, you can find out that if I connect the top of every bar, I would be getting a graph like this. A graph, smooth graph like this, right? So that means I'm getting a long right tail. So what is the inference? The inference is that my MSRP, it is having skewed data, and this is rightly skewed or positively skewed. So let me demonstrate what is this skewness, what is kurtosis. If I talk about the normal distribution, or which is also known as Gaussian distribution. So it is like this curve, bell-shaped curve, in which the data is symmetric and mean, median, mode, they are all equal. But if I don't have the normalized data, in that case, I might be having left skewed data in which the curve would be like this, or maybe right skewed data. So here the tail is towards right, so skewed towards right, or positive skewed, and the tail towards left, so that means left skewed. Now I'm plotting the same plot with the help of C-bond. Here the method is this plot, and with this plot I can plot both at the same time, histogram as well as KD plot, which is known as kernel density estimation plot. So I'm not taking here the histogram, so I have set false to that. And all the parameters for my KD plot I have taken in the form of a dictionary. So color is red, line width is 4, style is solid line, and opacity is 0.9. I'm also printing the skewness of my data with the help of this method. So now you can see what value I'm getting for skewness 2.79. So any value of a skewness between -1 to +1, it is good enough. It is very similar to your normal distribution. But if you're getting a value more than -1 or more than +1, that indicates skewness. So value of positive value of 2.8, it indicates the data, it is rightly skewed. And if you see the plot, so from the plot also you can infer that you're having a long right tail. That means there are certain outliers which are creating this longer right tail. And because of this right tail, the data is not 100% normalized. It is skewed towards right, so it is positively skewed. But kurtosis means the modality. So I'm getting a very single high peak. So that means kurtosis is nice for this plot. If I would not be getting a peak, so then my data would be something like this, and it would be flat from the top. Are you getting this thing? So kurtosis represent whether I'm getting a nice peak or I would be getting a flat distribution. So this means my kurtosis represents here a value above 0. So that means it is representing a marked peak. So kurtosis is above 0 in this case. Similar kind of representation I can do with the help of box plot also. In box plot, I have 5 numbers. So that's why it is also known as 5-number summary. I have a minimum value, Q1 quartile, which is also known as lower quartile or 25th percentile, median, which is also known as 50th percentile, and Q3, which is upper percentile or 75th percentile. And then I have a maximum value. So in this case, this box represents the 50% of the distribution, middle 50% of the data distribution. And this median value, if it is towards left, it indicates that the data is rightly skewed because I would be having the right portion heavy. So it is rightly skewed. And if the median is towards Q3, that means it would be having a left tail and it would be left skewed. Minimum and maximum, they are Q1 minus 1.5 times IQR away from Q1 and Q3 plus 1.5 times IQR away from Q3. And if there is any point beyond these minimum and maximum, that is treated as outlier. So this is the information which we get from the box plot. So here in this case, I'm plotting a box plot with matplotlib. So I'm using a command box plot and I'm passing MSRP. Symbol indicates that outliers would be represented by green color crosses and vertical set to 0. That means I would be getting a horizontal box like this way. And the width of my box, it is 75% of the total axis, right? I have given label for my x-axis. I'm getting a plot like this. And this shows that there are too many outliers in my data. At the same time, I want to represent the same box plot for the same variable with the help of method name is also same, but you can see with very few syntax, very small syntax, I have very nice representation of the box plot if I'm using C-bond. So that is the difference in matplotlib and C-bond. Here also, we are getting too many outliers. Obviously, it is same representation of the same feature. Now, next step would be that I should remove the outlier. So to remove the outlier, I have found out the Q1, Q2, Q3 value by using quantile method, to which I'm passing 0.25, 0.50, and 0.75. After I would be getting these three parameters, these three values, then I can find out IQR. So that would be the difference of Q3 and Q1. Now, from this data frame DF, I want to extract all those rows which are having any outlier. For that purpose, I have put this equation. I'm not going into detail of this equation. That also I have described in detail in my last workshop. So this DFN, DF1, it represents all the points which are not having any outlier. And finally, I have taken the MSRP from this new data set, new data frame. So if I'm representing again the box plot, you can see most of the outliers have been removed and I have only 3 outliers now. Next, coming to multivariate data. So for that, I'm using the relation. There are different 3 kind of correlations: standard, which is also known as Pearson correlation. Then there is Cantor-Tau and Spearman-Ram. This Pearson correlation, which is represented by a coefficient R, can have a value from -1 to +1. So if the value is 0, that means there is no relationship between 2 variables. Any value greater than 0 indicates positive direct linear relationship. Any value less than 0 indicates inverse or negative linear relationship. So here in this case, I'm finding the correlation matrix first on my DFN data frame using a method core, and I have provided that the method should be Pearson. So this C, you can see I would be getting a matrix like this, which would be having values between -1 to +1. So any value near to 1, positive relationship, and any value towards -1, it would be a strong negative relationship. For this C matrix, I'm now plotting a heat map. And then you can see here what kind of heat map I'm getting. See here, this is my heat map. And here, this bar represents that any value which is towards this color, maroon color, dark maroon color, it would be a positive linear relationship. And any color towards dark blue, it would be representing a negative relationship. So from this matrix, you can see that MSRP, which is outcome variable, it is having positive relation with engine size, a positive relation with cylinders, very strong positive with horsepower, a negative relation with MPG city, and a negative relationship with MPG highway, a positive relation with weight. So that means I can do feature selection based on this heat map, and I can take these features: MSRP, engine size, cylinders, horsepower, MPG city, MPG highway, and weight. But further analysis from this heat map, it says that cylinder and engine size, they further have very strong positive relationship. If one increases, other will increase. If one decreases, other will also decrease. That means they would be having similar kind of impact onto the outcome variable. So that means I can drop one of them. Similarly, I can drop one of MPG city, MPG highway. Further, weight can be dropped because it is again having a relationship positive with cylinder. So for feature selection now, I'm selecting only those input variables which are having high impact onto my outcome variable. So here I have plotted DF1. So from these DF1, now I'm extracting only some of the column: MSRP, engine size, cylinders, horsepower, and MPG city. So I'm extracting 4 columns now, right? For these 4 columns now, I'm plotting a pair plot. So in pair plot, you would be getting a scatter plot between every 2 variables. And from this, you can see now that even MPG city, it is not having very nice linear relationship with MSRP. So further, we can drop this variable, right? And after this now, finally, I'm giving the demonstration of interactive plotting for the scatter plot. So here you can see, this won't work in CoLab. So you can see here, you can focus here. this particular, I'm using notebook backend because notebook backend provides me interactive kind of visualization. And I want to plot scatter plot between horsepower and MSRP, cylinder and MSRP, ampagicity and MSRP, basically 3 scatter plot on the same graph. So for that purpose, I have extracted all those columns. I have plotted 3 scatter plot with the help of scatter method. And then I'm providing label to them. So legend would be displayed with the help of this method. If I'm running this cell, so you would be getting interactive graph like this. So what is the meaning of that? Basically, this is interactive. So if I want, I can pan around this visualization, right? So I have done like this. If I want to zoom a particular portion, I can zoom that as well. So I have zoomed this much portion of the plot, right? So this would be my next frame. Further, I want to zoom. So I'm taking this much portion, right? I have created lot many frames now. If I want to navigate among them, I can navigate like this, right? And after that, once you are satisfied with all kind of interactive visualization, you can stop the interaction from here. So this would convert it to static image now. So from this plot, we inferred that even the cylinders and ampagicity, we have seen vertical bar for them, vertical scatter plot. So they are not having very good impact over the horsepower. So over the MSRP. So finally, this horsepower, it is having the very nice linear, strict linear relationship with MSRP. So the inference out of all this visualization is that my input variable is now 1, which is horsepower, and outcome variable is 1, which is MSRP. So I can make a linear regression kind of model. So that can be created with the help of this visualization. This is the outcome of the visualization. And finally, here I have plotted the best fit model and the linear regression model. So I have taken only the MSRP as Y variable and horsepower as my X variable. The scatter plot has been plotted for the actual data points. And then to create a best fit line, I am using polyfit method with NumPy, to which I am passing my X and Y values under degree 1. This degree 1 indicates equation Y equal to mx plus c, which actually represents my linear regression model, where m is slope and c is the intercept. So I have created my model. After that, with the help of this model, I'm creating my line, model line. So my model equation is now y is equal to mx plus c. So I have printed these two. You can see I'm getting value of m and c, and thereafter I'm getting equation mx plus c. Here my c is a negative number. And then after that, with the help of this line of prediction, I'm plotting a line plot between x1 and the predicted values, which is my best fit model. So here you can see that all the points which are actual points which are represented with the help of markers, my best fit line, it is also fitting nicely with the points, because no other line fit to all these actual data points. So this is my linear regression model, which would give me the exact kind of analysis and the prediction for MSR. So if time permits, then I'm open for the queries. Thank you all for patient listening. Yeah, if any query, then I can take it up.
Perfect. Thank you so much to our speaker. One question from the chat is the following. Why are kernel density estimates used, and when are they preferred over other plots?
Yeah, estimation, it depends. Like if you want to go for classification kind of thing, then obviously you have to go, you cannot go for the linear regression, because it is mainly for the prediction of some outcome variable. And because here the purpose was I want to predict the MSRP. So that's why I went for I prefer the linear regression. But if I want to go for the classification, then different kind of models can be applied. Like in that case, we can go for the decision tree, or might be random forest, might be logistic regression. So it depends on the application or the problem we have in our hands. So accordingly, we can decide.